Welcome class. In today's video, I will talk about metamorphism. Throughout the quarter, we are trying to establish that the Earth's internal heat is the main reason for the existence of the different processes happening in our planet. Some of these processes are formation of magma, movement of the plates, earthquakes, volcanic eruptions. And in this video, what I am trying to point out is that we will focus in one process called as metamorphism. So let us define metamorphism. Metamorphism is defined as the process where a pre-existing rock transforms into another form of rock, and this transformation is due to the increasing heat and pressure in the Earth's surface or deeper surface. Now, this metamorphism caused the alteration in the composition of the rock. Technically, the minerals are rearranging itself to form another mineral which will be present in a metamorphic rock. Another thing, the changes in texture is happening in a rock as it undergoes metamorphism. So meaning to say, there is a change in the crystal present in a rock. Take note when we are talking about textural changes in a rock, meaning to say the crystal present in a rock are changing. So we can say from a smaller crystal, this crystal grows bigger as it undergoes metamorphism. So one example of metamorphism is happening in this type of rock. So shale is a sedimentary rock, and as it is undergoing metamorphism, changes in minerals and changes in crystals are happening on it. So shale will evolve into a slate, into phyllite, into schist, into gneiss as it undergoes metamorphism, changing the minerals in every rock type, and aside from that, changing the texture in every rock type. How does heat causes metamorphism? Heat causes rock to change its composition and texture. Once a rock is exposed to heat, the atoms and ions present in the minerals of the rock will recrystallize, rearrange itself, and create new minerals. It is just like cooking something. When you cook something, um, chemical changes are happening, which will in turn change its composition and physical characteristics. Now, I want you to take note that as you go deeper to the Earth's layer, temperature tends to increase, and metamorphism will only start once a rock is exposed to 200 degrees Celsius. And as the temperature increases, then there will be higher grade of metamorphism happening in a rock. Now, if a rock is exposed to a temperature between 700 and 1300 degrees Celsius, it may start to melt. So as you can see here in this diagram, at around 500 degrees Celsius, some rock are no longer undergoing metamorphism because it is starting to melt. So there will be less chances of rock turning into a metamorphic rock. And as references suggest, magma will start to form at 700 degrees Celsius to 1300 degrees Celsius, depending on the composition of the rock. But there are some metamorphic rock that are still forming once they are exposed to 800 degrees Celsius. Of course, this is depending on the composition of the rock itself. Aside from heat, pressure also causes metamorphism. The pressure exerted in a rock will cause it to become unstable, which will affect its minerals, recrystallizing it, and changes the rock's composition. Just like the temperature, the pressure exerted on the rock tends to increase as you go deeper into Earth's crust. And this pressure may be caused by the confining pressure or differential stress. In confining pressure, it is happening when the surrounding from all sides of the rock exerts equal pressure. So in this example or in this diagram, this is the rock which is exposed to different forces from different sides, different directions that are equal in amount. So metamorphism is happening on that. Um, this confining pressure is happening if the rock is simply buried in multiple layers of rock. So there is less movement of plates happening on it. Next, differential stress naman is happening if a rock is subjected to unequal pressure or forces. This is common if a rock is present in a convergent plate. So the movement of plates from both sides of the rock will give unequal pressure. So as you can see here in this diagram, the pressure is coming from different sides or from both sides of the rock, which will in turn cause deformity in the rock. And aside from the deformity, metamorphism is happening. Aside from heat and pressure, fluids, the removal or addition of it in a rock causes metamorphism. And when we talk about fluids, technically we are referring to the water present in the chemical composition of the rock. Just like what is happening in here, in shale as it undergoes metamorphism. Shale is technically composed of hydrous minerals, meaning to say water is embedded in its composition. But, but as it undergoes metamorphism, these hydrous minerals are taken away from shale, changing its composition and forming more crystals in it. Now, let us talk about metamorphic grade. Metamorphic grade is a general term for describing the relative temperature and pressure conditions under which metamorphic rocks form. Technically, we are just trying to point out here that if a metamorphic rock has a higher grade, meaning to say it is exposed to higher temperature and pressure. Just like here in this diagram, you can see here as the temperature increases, the grade of metamorphism increases too. So at around 200 degrees Celsius, there will be low grade metamorphism happening. Intermediate grade metamorphism is happening at around 200 to 400 or around 500 degrees Celsius. And high grade metamorphism may happen or may start at around 600 onwards. But if a rock is exposed to 700 degrees Celsius to 1000 degrees Celsius, then magma formation will happen. No more metamorphism, or there is less chance for metamorphism to happen on a rock. Do not get me wrong, because metamorphism is still possible in some type of rock if it is exposed to 1000 degrees Celsius. Now, same thing is happening if a rock is exposed to increasing pressure. As the rock is exposed to increasing pressure from 200 to 1000 MPa, then it is evolving from low grade, intermediate to high grade metamorphic rocks. When we are talking about metamorphic grade, the discussion of index minerals will always come in handy. So index minerals are just markers. These minerals will only be present if a rock is exposed to a certain range of temperature. So you have chlorite, muscovite, biotite, andalusite, garnet, and sillimanite as index minerals of metamorphism. So, chlorite will be present if a rock is exposed to 200 degrees Celsius to 400 degrees Celsius. And the presence of chlorite in a rock, in a metamorphic rock, will only say or will only suggest to you that it undergoes low-grade metamorphism or intermediate metamorphism or intermediate grade metamorphism. Same thing could happen if there is muscovite present in a rock. So we can say that it has undergone a low grade to intermediate grade metamorphism and is exposed to a temperature not greater than 600 degrees Celsius. Now, sillimanite will only be present if a rock is exposed to a heat that is around 800 degrees Celsius, meaning to say, this will be present in a high-grade metamorphic rock. We will talk more about metamorphism in my next video. Thank you.